and welcome to the first of a series of video tutorials on how to use Nanolyzer to analyze Nanopore data. In this one, I'm simply going to show you how to load a data set and visualize it and get started with the analysis process. Nanolyzer can natively load Chimera VC100 files, arbitrary binary files, of which NNi's data acquisition software will generate one type that we'll use today, and ABF files generally. So when you start to load a binary file, we're just going to load an example data set, which is 4 kilobase pair double-stranded DNA passing a solid-state nanopore. And the first thing that'll come up is this binary file preset, essentially. Most of the files you'll commonly use have a preset already there, NNi binary being one of the simplest ones. But if you have arbitrary binary formats, this will be able to map them using the custom option. Once you hit accept for your setting, you'll see that it plots the first 1 second of your data. And in this case, we already can see one DNA translocation event. By default, it's going to plot your raw data without any filter applied. If you want to filter your data, you can simply enter cutoff frequency and hit update trace, and you can see this change. But for today's tutorial, we're just going to use 100 kilohertz low pass filter, which gives us a nice balance between signal to noise ratio and rise times, which we'll get into in a future video. You can also zoom in to take a look at the data set. And you can see that in this case, the one event we're seeing in the window here is a typical double-stranded DNA event that starts off folded and ends up in an intermediate state, with the folded state being slightly attenuated because of the fact that it's quite fast compared to the bandwidth that we're using right now. You can also move around your data set. For example, we can plot 10 seconds instead of 1 second. And we can start to see a larger number of DNA translocations passing through the pore. Do be careful of trying to plot very, very large amounts of data. This is typically set up simply because of the data density involved in solid-state nanopore research. This is typically set up to plot only a few seconds of data at a time. If you try to plot minutes or hours of data, it's going to take a while to load. But for the time being, skimming through using just a few seconds of data at whatever bandwidth you like is one of the simplest operations you can do. Once you're satisfied with your filtration settings, that the events you're seeing are well resolved, the next step is to go to Data, New Analysis, and choose an output folder to store the output of the analysis run. If that already exists, it will prompt you and to ask whether or not you want to overwrite. And today we do. After a brief delay where it plots where it attempts to fit the baseline that you're currently looking at in the window, you'll see this new segment of controls appear here. This is the analysis setup, which we'll get into in some detail in the next video, as well as the baseline fit that Nanolyzer detects, the bounds on the baseline noise, and a suggested threshold with which to detect your events. We'll pause here, and in the next video, we'll walk through all of the one-time setup controls for analysis and get you started on actually fitting these events.